Hello, my dear students. Mr. Hassan with you. Today we will complete our first lesson, inshallah, the electric current and the electric current intensity and the potential difference. As we studied last week, we have talked about the electric current intensity. What's meant by electric current intensity? It is the quantity of charge that passes through 1 second. Okay? I equal what? Q over T. Amount of a charge in coulomb over time in second. Right. Also, we have talked about potential difference. What's meant by potential difference? Equal V equal W over Q. It is the work done needed to transfer a charge of one coulomb between 2 points. Between what? 2 points. Okay? As we studied last week. Okay? Today we will complete our lesson. The third point in this lesson talks about electric resistance. Electric what? Electric resistance. Okay. What's meant by electric resistance? When the car moves through road, there is some opposition that faces the car during its motion. Okay. Also, when the electric current passes through the wire, there is some opposition. Okay, faces the current, whatever the type of the material, maybe iron, copper, aluminum, okay, and so on. So there is something called electric resistance. It is the opposition that faces the electric current through its motion. Okay, we have two types of resistors. First type called fixed resistance. Fixed what? Fixed resistance. First type could what? Fixed resistance. Okay. Fixed resistance, it has a real shape like this. In our house or any electronic device, there is something colored like this. Could fixed resistance. When we draw it like this, straight line and the zigzag line and so on. This is called what? Electric resistance. Okay. What is its type is constant resistor. Constant resistor. Right. Second type, it is variable resistor or rheostat. Variable resistor or what? Or rheostat. Okay. Variable resistor or rheostat. It has a symbol like this. Maybe a zigzag line and has an arrow here, or a zigzag line and the arrow written here, or the third type or the third shape of this. This is the actual or the real shape of the rheostat. Okay. So we have two types of electric resistance. First one is fixed resistance. Second one is rheostat or variable resistance. It has variable value. Okay, not constant. Type. Ohm's law. It is an experiment which studies the relation between the potential difference and the electric current intensity. Okay, what is the structure of the device used in Ohm's law, or to get Ohm's law? Firstly, we have a battery, okay, and electric wires and rheostat. This is what? Rheostat and fixed resistance. And what? Fixed resistance. Right. Who can know what's this device symbolized by A capital? This device is called a meter. Called what? A meter. It measures the electric current intensity passing through the wire. What is the type of connection? It is connected in series connection. Connected in a series connection. Type. This device called voltmeter. It measures the potential difference across the two terminals of the electric resistance. Across what? The two terminals of the electric resistance. Okay? Right. Scientists make an experiment to study the relation between the potential difference and the electric current intensity. By what? By changing the value of rheostat. By changing what? The value of rheostat. When the value or the length of this resistance it changes, what the voltmeter changes and the reading of ammeter changes. When the ammeter reading increases, the voltmeter reading increases. Okay, and when it decreases, and so on. So V and I has direct relationship. Has what? Direct relationship. The slope of this relation represented by a constant value. Represented by what? A constant value. The slope of this relation represented by what? Constant value. This constant value represent what? Represent the electric resistance. The electric what? Electric resistance. Okay? When we calculate the slope of this relation, we will get what? The electric resistance. Okay? So the electric resistance here is fixed or variable? Excellent, it is fixed. Why? Because the slope of this relation gives a constant number. Constant what? A constant magnitude, a constant number, which it is the value of this resistance. Okay? So what is the importance of Ohm's experiment? Okay? Study the relation between the potential difference and the electric current intensity passing through the conductor. Okay? The structure of this device, a battery, electric wire, a meter, a voltmeter, and fixed resistance and variable resistance. By changing the value of this resistance or the rheostat, the voltmeter reading changes and also the ammeter reading what changes. Okay? Ohm's law at constant temperature, the electric current intensity has direct relation with the potential difference passing through the conductor. What does it mean at constant? What does it mean at constant temperature? At constant temperature, it means that it has a fixed resistance. It has what? A fixed resistance. The temperature of the wire is constant, doesn't change. Temperature of the wire what? Is constant and doesn't change. Okay? The electric resistance of the conductor, it is the ratio between the potential difference and the electric current passes through the wire. Okay? The measuring unit of the electric resistance equal what? The measuring unit of the electric resistance equal Ohm. Equal what? Ohm. Related to the scientist Ohm. Okay? Again, the electric resistance of the conductor equal the ratio between the potential difference V and the electric current intensity passes through the wire. And its measuring unit is what? Is Ohm. Okay? What does it mean, Ohm? Ohm, it is the resistance of the conductor which allows the electric current intensity of 1 ampere to flow through the conductor. When the potential difference equal 1 volt, equal what? 1 volt. Again, also meant by Ohm, it is the electric resistance. When the potential difference between the two terminals equal 1 volt and the electric current intensity equal 1 ampere. So 1 over 1 equal 1. Okay? We have notes here. There are two types of the electric resistance. First one is called ohmic resistance, which the resistance that obey Ohm's law. V equal what? Equal I times R. This could what? Ohmic resistance. What does it mean? Non-ohmic resistance. It doesn't obey Ohm's law. There is an opposition in the flow of the electric charges. We have another note here that the battery have an internal resistance. The battery have what? An internal resistance. The battery have what? Have an internal resistance, which is symbolized by what? By R smoke. Okay? We have an example here. Electric charges of 3.6 coulomb passes through an electric conductor with 1 minute. 1 minute means what? 60 seconds. Excellent. Time must be in second. If the potential difference between the two terminals of the conductor equals 300 volt, V equals 300, find or calculate its resistance. From the last slide, resistance equal what? The ratio between the potential difference and the electric current intensity passing through it. Okay? Type. Here we have the potential difference. What about the electric current intensity? From the last week, I equal what? The amount of a charge passes in 1 second. The amount of a charge passes in what? In 1 second. So the amount of charge equal 3.6 divided 6. 3.6 divided what? Divided 6. Okay? Equal 0.06 ampere. And this value is the value of I equal 300 divided 0.06 equal 5,000 A, 5,000 O. Okay? Right. We have an example here. Choose the correct answer. When applying the potential difference of 64 volt between the terminal of the wire 2 times 10 power 19 electrons, this is the number of electrons through its cross section each 1 second. Okay? So the resistance of the wire equal what? Like the last example, resistance equal V over L I. Okay? Right. We have the value of the potential difference here. Okay? Right. What about I? I equal the amount of a charge passes in 1 second. Q divided what? Divided time. What else, Mr.? We have here the number of electrons. We have what? The number of electrons equal 2 times 10 power positive 19. Electrons, the number of electrons. And we have the charge of each electron. This constant value E equal 1.6 times 10 power negative what? Times 10 power negative 19. Okay? The Q equal what? N times E over time. Over what? Over time. Okay? 2 times 10 power 19. Here we have a calculator. N times E. 2 times 10 power 19 times 1.6 times 10 power negative 19. Okay? Equal 3.2. Equal what? 3.2. Okay? Use electric current intensity here equal what? 3.2 ampere. 3.2 what? Ampere. Here we have finished? Not yet. He needs the electric resistance. Electric resistance equal what? Equal V over L I. Equal 64 divided 3.2 equal what? Equal 20 ohm. Equal what, شباب? 20 ohm. Okay? In this example, we have used two loads. The first one, I equal Q over T. Okay? Type. Q equal the number of electrons times the charge of each electron. Divided time. Time here equal 1 second. Okay? Another point, electric energy and the electric power. Electric energy symbolized by work. This energy equal joule. The measurement is joule. What does it mean? The work done by the electric charge when it compared into other form of energy through the electric circuit. Okay? So W or the electric energy equal power times time or V times Q. V times what? Times Q. اوكي. Q equal what؟ I times T. يبقى W equal VIT. W equal what شباب؟ VIT. يبقى فولت its measuring unit what؟ Joule equivalent to volt ampere second. Volt watt ampere second. Okay. طيب. Or joule is equivalent to volt coulomb. Volt times what times coulomb. Or another equivalent unit. W equal power times time. The measuring unit of power is what? Is what, شباب? Is what? Okay. So joule is equivalent to what? Another unit here is equivalent to what? Time is second. To what, شباب? What time is second? Okay, شباب? يبقى joule is also equivalent to a what time is second. Okay. طيب. It is very important point. Okay. You must know the measuring unit of each physical quantity and its equivalent unit. Okay. طيب. It may be an question in your final exam إن شاء الله. Okay. طيب. The electric power, the consumed electric energy with 1 second equal W over time. W means what? The work done in 1 second, or V times Q over T, or I times V, or I square, R, or V square over what? Over R. Okay? It has many equivalent units. What equal what? Joule over second, or volt coulomb over second, or volt ampere. Volt times ampere is also. Okay. What about this? Volt square over O. Volt power 2 dot O minus 1 is also equivalent unit. Okay. This is very easy. We have an example here. The opposite graph represents the variation of the consumed power on the conductor versus the square of the current in test. Firstly, we must know the law related between the power and the electric current intensity power 2. Okay? From the last slide, power equal what? Equal I square times R. Equal what, شباب? I square times what? Times R. Okay? طيب. What about this slope? The slope of this relation must or can be calculated from 50 minus 0 divided 10. 50 divided 10 equal equal 5. The slope of this relation represents what? The slope of this relation represents the electric resistance. Represents what, شباب? The electric resistance of the conductor. It is constant value. It is what? Constant value. Okay? Our answer will be letter B. To calculate the electric resistance of the conductor, it depends on the length of the wire. It depends on what? Length of the wire. As the length of the wire increases, the electric resistance will increase. It has direct relation. What about the cross-section area? The cross-section of the wire. It is very narrow or wide cross-section area. As the cross-section area increases, the electric resistance decreases. Okay? Like what, شباب? We have two cars moves in street. تمام? The width of the street may be 5 meters. Okay? And we have another two cars moves in the street. The width of the street more wider 10 meters. Which street will be easier for the two cars? The first street which has 5 meters or the second which has 10 meters to move faster? Excellent. The second street. Why? Because the second street is more wider, there is no resistance, or it has very small resistance. So each car moves freely. Each car moves what? Moves freely and moves fast. Okay? So as the cross-section area increases, huh, the electric resistance will decrease. So it has an inverse relation. Okay, شباب? Again, as the cross-section area of the wire increases, the electric resistance will decrease. So it has inverse relation. Okay? So here we have the electric resistance is direct relation with the length of the wire and the inverse relation with the cross-section area of the wire. So resistance equal constant times length over the cross-section area. This constant value is the electric resistivity. It is constant for the same material. Rho E. It's symbolized by what? Rho E. It's the electric resistivity. Could what شباب? Electric resistivity. Okay? Rho E is the physical quantity which is constant for the same material at constant temperature and equal resistivity of the material of the conductor or the specific resistance. Okay? Right. We have notes here. The rheostat can be used to control the electric current intensity through the circuit because by changing the position of the wire, the length of the resistance changes, so the electric resistance decreases or increases according to the length of the wire, and the electric current intensity has an inverse relation. Okay, I and R when V is constant. V potential difference equal what? I times R. When the potential difference is constant, there is an inverse relation between what? I and R. Okay? What are the factors affecting the electric resistance? Firstly, the resistivity of the conductor. It depends on the type of the material. How? When we use copper, it is different from using aluminum. Both of them are good conductor of electricity. Okay? Both of them are good conductor of electricity. Right. What about the conductor length of the length of the wire? There is direct relation. As the length of the wire increases, the electric resistance will increase. Okay? Right. What about the slope of this relation? When we get the slope of this relation from this law, R over L equal what شباب? Equal rho E over LA. So when we get the slope of this relation equal what? Rho E over L area. Right. The cross-section area, it has an inverse relation, but we make the relation here between R and 1 over LA. Okay? If we make the relation between R and A, it has an inverse relation. That's what شباب? An inverse relation. Okay? Like this. But here we make the relation between 1 over A. Okay? Right. The slope of this relation equal rho E L. The electric resistivity times L, and rho E is constant for the same material. Right. When we make the relation between 1 over R squared, it's also the same of this A relation. R 1 over A, it has direct relation between 1 over R squared. So the slope of this relation equal rho EL over pi. Why? Because the cross-section area of the wire is like a circle. Okay, like what? Like a circle. So the area of this circle equal pi r power 2. Pi r ايه يا شباب؟ pi r power 2. This is the area of the circle. Okay? Right. The resistivity of the conductor symbolized by rho E, like this شباب, could what? Rho E equal R A over L. The resistance of the conductor of length 1 meter and the cross-section area equal A of 1 meter square. At certain temperature, It is measured in ohm meter. Measured in ايه يا شباب؟ ohm meter. The measuring unit of the resistance ohm and meter. Okay? Why, Mister? Huh? Look at here. Resistance measured by ohm. Okay? And the area measured by what? By meter square. Huh? Divided meter. Divided what? A? Divided meter. Hmm? We have square here, huh? And meter. So we get ohm times what, شباب? Times meter. So the measuring unit of the electric resistance, sorry, the electric resistivity equal ohm meter. So it depends on what? The type of material and the temperature of the conductor. Type of material and what, شباب? And the temperature of the conductor. Calculate the radius of the copper wire of the uniform cross section area of a length 25 meter. Okay? Of the resistance equal 0.1 ohm. The resistivity of the copper equal what? Huh? From the first law, this law, we can get the radius of the conductor equal what? Equal R equal rho E L over A. Here we have the resistance, we have rho, we have the length, so we can get the value of the radius of the wire from this relation. Okay? Choose the correct answer. Which of the following graph represents the relation between the resistivity of the material and its length? Huh? Which one? It is constant, it is direct relation, inverse with linear, inverse with with square or curved line. Which one? Excellent. Letter A. Why, Mister? Because it depends on the type of material and the temperature, and there is a length. Right. Another example. If we have the relation between the electric resistivity and the cross-section area. Electric resistivity and the cross-section area is also a constant. Doesn't it change or doesn't affected by the cross-section area of the wire. Okay, شباب؟ طيب. Here we have another physical quantity called what? Called the electric conductivity. Called what, شباب? Electric conductivity. Okay? Electric conductivity symbolized by letter sigma. Letter what, شباب? Letter sigma. Electric conductivity symbolized by letter sigma. Okay? طيب. Conductivity equal ايه؟ Equal the reciprocal of the resistivity. Reciprocal of what? Resistivity. يعني means 1 over rho E. 1 over what, شباب? 1 over rho E. It is constant value. So conductivity is also constant. Okay? And we can get from the relation length over R times A. Okay? The electric conductivity sigma is the reciprocal of the resistance of the conductor of length 1 meter and the cross-section area of 1 meter square at certain temperature. Its measuring unit is what? Reciprocal of the resistivity. Resistivity measured by ohm to meter. So it's the measuring unit of the conductivity equal ohm minus 1 meter minus 1. Okay, شباب؟ طيب. Factors affecting the electric conductivity like the electric resistivity, the type of material and the temperature, and the relation between them are a inverse relation. So the slope of this linear relation equal or direct relation equal 10, 45 equal 1. Okay? The electric resistivity, we have notes here. The electric resistivity and the electric conductivity are characteristics, physical property for the conductor. Doesn't it change? Okay? Because both of them depends on the type of material at constant temperature. Okay? When temperature increases, the resistivity increases, and the conductivity will decreases. The electric transmission cables from the electric power station are made up of copper because the resistivity of the copper is small and the resistance of the copper wire is small, so the conductivity is direct relation. Okay. Thank you, Shabab. We have finished.